Well, welcome back, Mr. Kolazar's chemistry class. Today we're going to be talking about how to measure. And so one of the things we're going to be looking at today is, depending on what device you have, is going to be how small or how precise you're actually going to be able to measure. So our first object or idea is to find the smallest graduations on your measuring device. Now, if you're looking at like a meter stick, if you're measuring the length of something, if you were to look at the meter stick, one of the things on there are a bunch of small markings. Now, as you're going across and looking at those, what we're talking about with the graduations is how much distance is there between each of the two markings. Or if we were to look at, say, a graduated cylinder, how much volume is measured in between each of the markings. We call those markings the graduations. Now what we're going to look at, first off, you need to determine the space between each one, how much is being measured, and then part two, when you make your measurement, you're going to estimate one place value more accurate than your measurement. So what we're looking at is, if our numbers are in between these two spots, we're going to estimate where exactly that measurement might be. So we're going to estimate one further spot than what our actual device can measure. It's going to make our measurements more accurate. Now as we're going, there is no perfect measurement device. You could always become more accurate or more precise as you're measuring, and that's our key idea, is that we're just trying to become more accurate with each measurement. Now the more we practice this, the better we're going to get at it. So what we're going to look at now is a couple practice problems. These ones are not in your notes. We're just going to have you follow along for these first two. If we look to the left, we start out at 25, down to 20 on this graduated cylinder. Now we have our curved liquid in here. Remember, the meniscus is that curving of the liquid caused by the attraction of the container. We always measure from the bottom of that meniscus line. That's how the devices are made or created. So as we're going, we see 25 down to 20. So this would actually say 21, 22, 23, 24 milliliters, and finally the 25th milliliter. So these are all 1 milliliter marks. So what we're going to look into is, if we're between 25, or 20 and 25, 21, 22, 23 is where we're at. So we're somewhere between 22 and 23. Looking eye level, down to that bottom of the meniscus, we could see that we're about halfway. So our measurements would be somewhere about 22.5 units, always needed, milliliters. So we know we're between 22 and 23. We estimate that last or one extra placeholder spot to 25. Our second example is, instead, if we look over on the right hand side, graduation, we're 1 milliliter on the left, measuring down to 1/10. On the right hand side, we started out at 8, go down to 7. So on the right hand side, 0.1 millimeter graduations, we could see 7.1, 7.2, 7.3, 7.4, 6, 7, 8, 9, finally 8. So if we were to estimate one place further, we would measure to the nearest hundredth. 7.1, 7.2, 7.3, 7.4. We draw right across. We're basically right about 7.4. Now if we were going to estimate one further spot out, since we're right at the 7.4, our actual answer is not 7.4, but 7.40 milliliters, since we landed basically right on that line. Maybe 7.41 if it's just barely above that line, or 7.39 would be a little bit lower. but we're going out to that estimated 100th spot. We're estimating that final spot just like we estimated that final spot on the first part. The two problems we have to look at for today that are in your notes. Our first example, first off, we need to find out what the smallest increment on our graduated cylinder is. Whoops, didn't quite make that there. So starting at 5, moving to 10, these increments on the side would move up to 6, 7, 8, 9, and 10. So our smallest increments on here are 1 milliliter. What volume is in here? So if we're going to the smallest increments, we're going to estimate that one extra spot. So in this case, we're at 5, 6, 7, between 7 and 8. That's where our line would end up going. So in between 7 and 8, we're at about 7.4 milliliters. Maybe 7.5, maybe 7.6, but right in that area. So we're estimating that one extra spot. If we measure to 1 milliliter, we're going to estimate to an extra tenth of a milliliter. So to the 0.1 milliliters is where we'd estimate to. One extra spot is our key. We're going to estimate that one out to be more precise on our measurements. Our final example for this part, measuring out what is the smallest increment of measurement on this scale. So if we were to look at the side, in your notes started with 4, goes up to 5 milliliters of measurement. So each measurement here, 4.1, 4.2 milliliters, all the way on up to the top to 5 milliliters. So if we're here, measure straight across, 4.1, 4.2, 4.3, 4.4, maybe just over 4.4. Smallest graduation marks on this one this time were 1/10 of a milliliter. So we're going to measure down to, what we're going to measure down to here is we have about 4.4. And then if we were to go a little bit further, 4.4, we estimate that one extra spot, maybe about 4.41 milliliters, since it's just above that 4.4 mark. Now as we're going, this last spot is the one we estimate. As long as we're close on this one is what we're looking for. So our key part is always remembering that whatever we're going to be measuring or using as a measurement, we can estimate out that one spot further to make our answers a little bit more precise. We'll be measuring in class, so we'll be using this technique all year. So just be aware of it now because we're going to continue to practice and use it as we're going.